We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 16, Exercise 16.1. This is of surface area and volume. A copper sphere of radius 3 cm is melted and recasted into a right circular cone of height 3 cm. Find the radius of the base of the cone. So when this type of question comes, that means we have to equate the volumes. Copper sphere is there and it is recasted into a cone. So the copper sphere, the radius is 3 cm and the right circular cone, the height is given. The height is given as 3 cm. So we'll just equate the volume. That is, what is the volume of a sphere? It is 4 by 3 pi r cube. So we'll take it this as 3, and then this one is a cone, and we know the volume of the cone is 1 by 3 pi r square h. Height is 3. We'll take it 3. This cancels this 4, 3 pi by 3 and pi by 3 cancels. We have 4 by 4 into this 3 cube equal to r square into h. What is this? H is again 3. So what do you get? 4 3 is a 12, 12 3 is a 36, and r square is 36. So we get r as 6. So the radius of the cone is 6 cm. A copper wire of diameter 1 cm and length 8 cm is drawn into the wire of length this meter, 18 meter of uniform thickness. Find the thickness of the wire. So here two same shapes are there. So one shape is converted into the second shape. So we have a copper wire. Now this has a diameter of 1 cm. And if you see, this is 18 meters. So the units have to be changed. So let it be in centimeter. We'll change this into centimeter. So the diameter is 1 cm. Radius will be what? Half of this. So it will be 0.5 centimeter. Radius is this much. The length is 8 cm. Let us say that length and height. So height is 8 cm. Into wire of length 18 meters. So we have a wire. Now the wire here, the height is, length is 18 meters. So we'll convert it into centimeters. So it will be 1800. I'm multiplying it by 100. It will be 1800. And of course the radius has to be, because thickness is what we are interested in, thickness and radius are same for a cylindrical type of wire. So radius we have to find out, and height and r is given. Okay. Now let us equate the pi, the volume of this one and volume of second one. So pi into r square, which is 0.5 square, into h, that is 8, equal to pi, r square we don't know, and h is 1800. This will be 0.5 whole square into 8 by 1800. So when we solve it, we are going to get the r as 0.033 centimeter. This is the answer. The diameter of internal and external surface area of hollow spheres are this much and this much, 10 and 6. If it is melted and recasted into a solid cylinder of length this much, 2 by 3, find the diameter of the cylinder. So here now we have a hollow, cylinder like this, and this is casted into, this is a hollow, it's a hollow spherical shell. It's a hollow spherical shell. It is melted into a solid cylinder. So let us assume that this is a solid cylinder and this has come from a hollow spherical shell. So hollow spherical shell, that means we have this type of diagram. So a hollow spherical shell is converted or recasted into a cylinder, solid cylinder. So I'm just keeping this out. It is a proper cylinder like this. So now the diameter of internal and external. So internal diameter is here. The internal diameter is 10 centimeter, internal, and external surface area. The diameter of internal and external surface area. So 10 centimeter, 6 centimeters. So outer one is 10. This is 10, and this is 6. So 10 is the diameter. So radius will be 5. External, and our internal is 6 by 2 will be 3. So the volume of this one will be volume of this one. Okay. So what is the volume of the sphere? volume of sphere is 4 by 3 pi capital R cube, that is this RE. Let me write just this as capital R and this as small r. R cube minus the outer one minus the internal one, so 4 by 3 pi small r cube, and this is going to be equal to the volume of this solid cylinder, which is pi r square h. So pi into r square, because the diameter or the radius has to be found out, so it will be r square, and height is 2 by 3. What is 2 by 3? 3 to the 6, 6 plus 2 is 8, so it is 8 by 3. So what do we get? Pi I can cancel. We get 4 by 3. Now what is the outer volume, outer radius? It is 5. So 5 cube minus this is 3 cube. And this is 8 by 3. So 3 goes up, 8 comes down. And this is r square. So we have 3 cancels, 4 2 is 8, 1 by 2, and 5 cube minus 3 cube, and just take the under root of this. The radius will come as 7 centimeter. Yes, it is 7 centimeter. So what is the diameter? Because question is asking diameter, not the radius. So diameter will be 2 into r, that is 2 into 7, which is going to be 14 centimeter. How many coins of 1.75 in diameter and 2 millimeter thick can be melted into a cuboid, melted to form a cuboid? So how many of this? We don't know how many of these, and the coins are of course in the form of a cylinder. If you take a coin, you see there is a thickness also. There is a thickness also, so it is type of a cylinder. And when this cylinder, how many cylinder of this type has to be melted? So let us take that there are n cylinder type of these coins. And what is the volume of this coin? Because it is, we are assuming it to be a cylinder. It is a cylinder. It will be pi into r square. Now this is 1.75 centimeter. Let us keep everything in the centimeter. 1.75 into h by 2. This is diameter, so I am just making it as a radius. 1.75 by 2, and 2 millimeter thickness. So height is 2 millimeter. 2 millimeter I have to change. I have to change 2 millimeter h, which is 2 by, you just take because it is centimeter, just take 2 by 10. It will be 0.2. This will be equal to melted into cuboid, and the volume of the cuboid is already given. So 11 into 10 into 10. So all these things we have, just keep it, take everything here, n will come as 1600. Because everything is here, pi is known, this is known, this is known, these all they are known, and will come as 1600. 1600 coins are required. The surface area of a solid metallic sphere is 616. So we have a solid metallic sphere, and 616 is the surface area. It is the surface area, centimeter cube. The surface area, since it is centimeter cube, so we are just bit confused, and because it is a surface area, area cannot be in cubic meter, so we'll just see that. Okay, now coming to the, it is melted and recasted into a cone of height 28 centimeter. It is, so it has to be centimeter square, and it is melted and recasted into a cone. Now we have to have a cone, and this cone is of height. It is height is given as 28 centimeter. 28 centimeter. Find the diameter of the base of the cone so far. So we have to just equate the volume of this one, and this is the surface area, and surface area of a metallic sphere or a sphere is 4 pi r square, and this is equal to 616. So all known, r square is 616 by 4 pi. You have to take the root of this. R will be equal to 7. This you can do. Okay, R will come as 7. So we'll equate now the volume of this one equal to volume of this one. And what is the volume of a sphere? And what is the volume of a cone? Volume of a cone is 1 by 3 pi r square h, which is 1 by 3 into pi, and r square we don't know, we have to find out, into h, and height is known, 28. This height is known. I am taking about, this is the volume of the cone, and this is equivalent to the volume of the metallic sphere, which is 4 by 3 pi into r cube, and we just found r cube. This is 7 cube. Okay, so this pi by 3 cancels. You have r square as the 4 into 7 cube by 28, and this, if you take the root of this, this is going to come as 7 again. Now 7 is the radius, but the diameter has been called for. The diameter is 2 into r, it is 2 into 7, it comes to be 14 centimeter. So this is the diameter of the cone. A spherical shell of internal and external diameter this much is melted and recasted into a cylinder of diameter 14 centimeter. Find the height of the cylinder. So this type of question we have already done, but we'll try to do it again so that we get the feel of that how the question can be just twisted and it remains same. A spherical shell. So it's a spherical shell. Internal and external diameter are given. So 6 is the internal diameter, so we just take this as the radius, so it is 3. 6 by 2 is 3. And how about the external one, which is 10? 10 by 2 is 5, so this is 5. Is melted and recasted into a cylinder. So we have a cylinder here. A cylinder of diameter 14 centimeter. Now the diameter of cylinder is 14 centimeter, so 14 centimeter is the diameter, radius will be 14 by 2, that is 7. So we'll just equate the volume of these two. What is the volume of this sphere? It is 4 by 3 pi, and we'll take the external one, pi cube, minus the internal one. So volume of external one minus volume of internal one will be the volume actually. So 5 cube minus 3 cube. This is equal to the volume of this one, pi into r square, which is 7 square, into h. H we don't know. Let us say it is as h. Pi cancels. 4 by 3, 5 cube minus 3 cube by 7 square. And the height will be, if you compute it, it will be 2.666 centimeter. I hope you'll be able to do it. This is 2.666 centimeter. Just verify. A hollow sphere of internal and external diameters this much is melted into a cone of base diameter 8 centimeter. Calculate the height of the cone. Again, we have a hollow sphere. So we have a hollow sphere again. And this hollow sphere has internal and external diameters as 4 and 8. So radius will be 4 by 2, that is this is 2 and this is 8 by 2, so this will be 4. Internal is 2, external is 4. It is melted into a cone of base diameter 8 centimeter. So it is a cone. The base is 8 centimeter. We have to find out the height. So we'll just equate the volume of this one equal to volume of this one. What is the volume of this one? 4 by 3 pi. External, that is 4 cube minus 2 cube, 4 by 3 pi r cube, minus 4 by 3 pi r cube, radius is 2 and 4 and 2. And this is 1 by 3 pi into r square. 8 is the diameter, so radius will be 2. 2 divided by 2, that is 4. 1 by 3 pi r square, so 4 square into h. So all values are here. The h will be 4 cube minus 2 cube by 4 square into 4. Just compute it, it is going to be 12 centimeter. A path 2 mm wide surrounds a circular pound of diameter 40 meter. How many cubic meters of sand are required to grave the path to a depth of 20 centimeter? So here we have a circular pond and there is a path. This is a path which is 2 meter wide. And the diameter of this internal one is 40 meter. So this is radius will be 40 by 2. So 20 is the radius. 20 is the 40 meter is the diameter. So radius will be this 40. Okay, it is 20, right? Now this is the internal diameter, and what will be the external diameter? See, the width of this is 2. So 20 plus 2, that is 22 here will be the external diameter. So what is the area, or you can say volume of this portion? It will be volume of the external one, and it is a circular pond. So we can assume it to be a cylinder, like a hollow cylinder. It is, because it is height also. It is given that we have to talk about width also, but that is the depth of the path. So it is essentially these two can be assumed to be a cylinder. So outer cylinder is pi r square h, that is pi into r, that is 22 square into depth, and depth is, see, the question is, we know that the thickness is 20 centimeter. The thickness is 20 centimeter, And when we say that it is 20 centimeter and when this is in 40 meter, 20 centimeter, because this is 2 meter, 20 centimeter, we have to convert it into meter. So divide 20 by, you have to take the pi r square h. Let me just tell you this. 20 is the depth, and when the depth is converted into 27 into meter, it is going to be 0.2. 0.2. Okay. Now this 0.2, how many cubic meters of sand are required to grave the path of a depth? So this is pi, nothing but pi r square h, that is 0.2 into minus pi into internal one, 20 square into h. See, what we have done is, this area is our hollow cylinder, and the height from here to here, this height is given as 20 centimeter, or if it is 10 centimeter, you have to see the book. I'm just taking it for an example. It is say 20 centimeter or 10 centimeter, whichever it be. So assume it to be 10 or 20. So just 20 by 100 or 10 by 100 is going to give you 0.2 or 0.1, either of them. So we have to multiply, we have to take the volume of the internal one, and that is the volume which is required, how many cubic meters. So what we do here is, pi is 22 by 7, 0.2 comes here, or 0.1, which is in the book, whichever question is there. 22 square minus this 20 square. So when you compute it, it is going to come as 52.77 meter. So this is the sand needed to spread across for this depth. So just take the volume of the external one minus volume of the internal one. This is the answer. A 16 meter deep well with diameter 3.5 meter is dug up, and the earth from it is spread evenly to form a platform, which is this by this. Find the height of the platform. Now, what is happening here is, there is a well, or you can say a pot which is being dug up. It is 60 meter deep. So 16 meter, the height is 16 meter. Diameter is 3.5, so radius will be 3.5 by 2. This is radius. Now this is a cylinder. When you dug up, if you see a well, it looks like a cylinder. So the volume of this one will be pi into r square, that is 3.5 by 2, it is equal to 1.75. 1.75 whole square into height, which is 16. And this is going to be equal to, it is evenly spread to form a platform of this by this. What is the height? So length and breadth are given, height is not known. So the volume of the platform will be length into breadth into height. So we just equate it to this one. 27.5 or into 7 into this height we don't know. So pi is known, just take it as say 22 by 7 and put this 27.5 here and 7 here. Everything is known. Height will come as 0.8 meter it has come. So you can just make it as 80 centimeter. So height will be 80 centimeter. A well of diameter 2 meter is dug 14 meter deep. The earth taken out is evenly spread all around it to form an embankment of height 40 centimeter. Find the width of the embankment. So this question is somewhat different from the previous. What is happening here is, so this is the dug up well, and the dug up soil, the earth which is taken out, is spread around this like this. This is also a kind of cylinder. Okay. So what we have to do here is, the volume of the the soil being dug up, will take the volume of that. That is equal to the volume of the sand, or you can say the earth which is distributed here to form an embankment. Embankment is also a cylinder. Okay. So volume of the dug up is simply pi r square h. So pi into r. Diameter is 2 meter. So we take 1 into height 14 meter. So this is 14 pi. Now let us take this one separately. So this is the well, and we are talking about this outer one, which is a cylinder. So let us assume that the width of this is x. This is x. And what is the radius from here to here? It is given that a well of depth 2 meter. So it is 2 meter. So 2 meter, that is radius will be 1. So we'll find the volume of the outer one minus volume of the internal one. So we get this area. Okay. This area we get. So what is the volume of the outer one? Pi r square. What is this? 1 plus x. Radius will be 1 plus x. 1 plus x whole square into h. H is the height of this one from here to here. This one from here to here. This from this to this is 40 centimeters. So just divide it by 100. So you get it in meter. It will be 0.4. Okay. Minus pi into, now what is the internal radius? Because outer minus internal, pi 1 square. Pi 1 square into 0.4. So this is equal to this 14 pi. Let me just remove this pi. So what do we get? 1 plus x whole square minus 1 square will be equal to this 0.4 also comes out. This is common. So I am taking 0.4 here on this side. So it will be 0.4. Let me solve this one first. 1 plus x square is what? 1 square plus x square plus 2x minus 1. So 1 gets cancelled. This x square plus 2x. Now this is 4 by 10. So what do you get? 2 to the 4, 2 5 is 10, and 2 7 is 14. So you get 35. So I am bringing it here now. Minus 35 equal to 0. And we know that this 35 can be written as x square. 7 5 is 35. So minus, say, plus 7x minus 5x minus 35 equal to 0. So x plus 7 I am taking, minus 5, x plus 7 equal to 0. So we get x minus 5 and x plus 7 equal to 0. X minus 5 will give us x equal to 5. X plus 7 will give us x equal to minus 7. So what you see here is this minus 7 cannot be taken, height cannot be negative. So x equal to 5 is the answer. This is the width of the embankment. So these were the question and answer of this topic, but we still have few questions left that we are going to take in the next discussion. Till then, thank you so much and take care of yourself.